Okay, so now I'm going to explain how to use the Pythagorean theorem as a distance formula, or to find the distance between 2 points. So first of all, if the distance between 2 points on the plane is vertical or horizontal, you can just count them. So for example, if I have a point here and a point here, which is a horizontal distance there, I would just count 1, 2, 3, 4. So the distance is 4. And I think these are centimeters, so we'll say it's 4 centimeters. Okay, or you could just say 4 squares. Okay, and if it's vertical, you can do just the same thing. You can kind of just count them. So if I have a point here and a point, whoops, all the way down here, let's pretend that line's straight, then I would just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 squares or 9 centimeters. Okay, so the distance vertically or horizontally, you can just count. But if you have a distance that is, the distance is diagonal, you can't just count it. So you have to use the Pythagorean theorem, which also becomes the distance formula. So the steps are you'll draw a right triangle with the 2 coordinates as the vertices, so as the ends of the hypotenuse, and then you'll connect those lengths of the legs to, and those values will be A and B, and then you'll use the Pythagorean theorem to find the distance of the hypotenuse. So let's look at a point, and I'll get it a little bit closer. So kind of to look at those steps, you'll draw the right triangle, and then you'll count the lengths of each leg, so the vertical and horizontal lengths of the legs, and those will be A and B, and then you'll use the Pythagorean theorem. And then we can write this also as the distance formula if you'd like to see that as well. So let's say the point is, one point is here, and the other point is all the way over here. Okay, so now we'll draw a right triangle, so we'll go kind of down to this point. So here are our 2 points, and if I don't have a ruler, I'll just kind of use that one. And this is the distance we are trying to find. Okay, that distance right there. Okay, so now we're going to connect the other 2 sides. So we'll make a right triangle out of it. So there's one side, and here is the other side. Okay. And we'll call this our side A. So A, and then we'll count it 1, 2, 3, 4, 5, 6. So A is 6. And our side B, and it really doesn't matter what letter these are. 1, 2, 3, 4, 5, 6. Oh, B is also 6. Okay, so then when we do our formula to figure out the side of the hypotenuse, we'll do that A squared plus B squared equals C squared. And in this case, it's 6 squared plus 6 squared equals C squared. 6 squared is 36. Okay, so C squared is 72. And remember, to get rid of that squared, we have to take the square root. So the square root of 72 is C. Okay. Now, some of the homework asks you to round these to the nearest tenth. You don't need to worry about that really, but if you wanted to round that to the 10th, then you would just take and put the square root of 72 on your calculator, and that would be fine. So now, the way this is written in what's called the distance formula is this way. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So this whole formula here is the distance formula, and that seems like it's not what we just did, but it is. Because if you look at this x2 minus x1, it's this right here. It's the distance in the x. So this x-coordinate was 2, and this x-coordinate was -4, and 2 minus -4 is 6. So that's what you just did there. And then same with this y2, here, let me use a different color. This y2 minus y1 piece here, we did the same thing here. So, and in this case, it just happens to be 2 minus -4 again, which is again 6. And so you squared those 2, right, like this, and then you did the square root. So it's the same exact thing. And I'll do that on the next one with a positive example that's all positive. So it might be a little easier to understand. Okay, so here's example 2. That's kind of way above. So we're going to do one that's a little bit, it's in the positive area, so it's a little bit easier. to look at here. Okay, and we're going to draw our line again, since I did not grab a ruler earlier, or check if I have one. So there's my distance, and I want to figure out how long that is. Now, we can think of it either way we want to. So you can either count your y distance, which would be, so the y2 minus y1, if you want to think of it that way. You can also think of it that way, but 1, 2, 3, 4, 5, 6. I could either count it and just say it's 6, or I could say it's 7 minus 1, which is also 6. Okay, and then I'm going to do the same thing for my x coordinates here. So I could do x2 minus x1, and I can again just 1, 2, 3, 4, 5, 6, 7, and count it like that, or I could say that's 8 minus 1, which is 7. Okay? And then I'm just again going to do that formula for the Pythagorean theorem. I'm going to do 6 squared plus 7 squared equals c squared. And this here is that c. Okay? And that's 36, in this case 49. Okay? And 36 and 49 is 85. So then you'll take the square root, and square root of 85 is c. Okay, and you could, if you wanted to, round it to the nearest tenth if you had a calculator, and that would be fine. Okay, so I'm going to do a couple of problems on what's going to be your homework. Now, you're only going to be asked, now specifically, I want to be clear, don't worry about like verifying the answer, and you can round it to the nearest tenth. I'll show you how to do that just on one problem, but I'm only going to ask you, in fact, I'll put it on Google Classroom that I only want you to do like 3 of these. It's not that important that you do, but you don't need to verify the answer because you've basically done the exact same thing. So anyway, so I'm going to do, let's do this problem right here, number 2. So here's 1, that distance is 1, and this distance, rather than, I'm just going to count out 1, 2, 3, 4, 5, 6, 7, 8. So I would do 8 squared plus 1 squared equals c squared. 8 squared is 64, 1 squared is just 1. Okay, so 65 equals c squared. Square root of 65 would then be c. And I would normally be fine if you left it that way, but if you did want to take the square root of that, then you would take square root, you would take 65, and in my calculator's case, I just take the square root, and it says 8.06. So to the nearest tenth, that's around 8.1. Okay, to the nearest tenth. So that's how you would do that. Okay, now you're going to be asked to do some problems on this one, and then and a few of these word problems. So we're going to do the baseball diamond one here. So between first and third base, so they're trying to give you, the baseball diamond is a square with sides of 90 feet. So if this is a square diamond, and I know this is not going to be the best drawing in the world, close enough. Okay, so, and they want to know between first and third base. So here's first and third base, and each one of these is 90 feet. And it does say, again, to the nearest tenth of a foot. So I would do 90 squared plus 90 squared, and that equals c squared. Okay, and 90 squared is 8,100. Okay, and then I would add those two up. So that's 16,200. And then I'm going to take my calculator and say 16,200. And then what is the square root of that? And it says 127.27, and this said to the nearest tenth. So around 127.3 feet. Okay. So you're going to have some problems to choose from that as your next work. Have a great day. Thanks.